Okay, the next feature I would like to show you is sweep. We often use this command to create some simple or variable sweep features with an open or closed profile and also a sweep path. And in ZW3D, the path can be a wireframe, an edge, sketch, or a curve list. Okay, and in ZW3D, we have four common sweep commands: sweep, sweep rod, profile sweep rod, and spiral sweep. Now let's see it one by one. For sweep, you can use it for most cases, and you need to define its profile and its path. And also, you need to notice that the path must be a tangent path. Okay. And for the second one, the sweep rod, we do not need to define its profile because its profile is a circle. Yes, and of course you need to define its path, and the path can be tangent or can be intangent. Okay, and the typical scenario is some pipe or harness, like the below image. Okay, and the third one is profile swept rod. This one is similar to a sweep rod, but you need to define its profile, and also you need to define its path. But its path can be tangent or can be intangent. Okay, and the typical scenario is about some steel profiles, like below you can see some welded steel profiles. Okay, and for the last one is spiral sweep. This one is normally used for some solid thread, and this one is different with the sweep the rod. Actually, it's on the contrary, because we need to define its profile, but we do not need to define its path, because its path is like rotated along the cylinder face. Okay, so we do not need to define its path. And for sweep, there are some advanced options, like the frame of the result and also the Z and X axis of the result. Here I have two cases to show you. So for the first case, you can see we have a profile here and we have a path here. And the profile the path is not at the same frame, right? They are separated. So you can see here I show you three results here. So based on different frame settings, like the first one is default frame, the second one is at intersection, and the third one is along the path. Okay, and later I'll show you detail in ZW3D. Okay, and for case 2, you can see we have a profile like this, and we have a path like this. And if by default you can see the x-axis of the result will be minimum twist. Here you can see the result. Some geometry even buried in the cylinder face, right? This is not what we want. So we can change the x-axis to face normal, and the face will be the cylinder face of the bolt. Okay, and the result will be like this. This is exactly what we want, right? Okay. So now let's move over to ZW3D to show you more details. Okay, here we have got a case. We got a profile and a path. And here you can see the profile and the path is separated. And also you can see the start point of the path is not located in the profile plane. Okay, here we'll use this case to show the sweep feature. Okay, here we click on sweep. And here you can see the required input is profile and path. Okay, first we select a profile and then we select the path. Okay. And now you can see the preview. And as I said before, there are some orientation settings. First, let me show you the frame settings. Basically saying the position of the sweep shape is controlled by the frame settings. So let's take two of them as an example to show you. The first one is also the default one, is at intersection. Okay, let's rotate it a little bit. Okay. For the default setting, which is at intersection, you can take it as moving the path to the centroid of the profile and then do the sweep. So this can cover most cases. Okay, now let's see another. It's the first one, default frame. Okay, we change it. And here you can see for the default frame, the sweep shape will follow the sweep path, which means it will be built at the start point and the end point of the path. Okay, that's the difference. And there are more settings like add path, along path, and you can select it a frame. Okay, here we just use the default setting at intersection. Okay, we click OK to get the result. Okay, this is the result. Okay, although we have so many frame settings, we still recommend you to move the path and the profile together. For example, we can make the profile and the path as below. Okay. Then if you do it again, you will see profile path. No matter you change the frame setting to default frame or intersect it or even add a path, it will be the same result. Okay. Okay, this is about the frame settings. And there are more orientation settings. Let's redefine the sweep feature. Okay. Next, I'll show you the z-axis and x-axis settings. You may notice that there are so many virtual frames when doing the sweep features. And there is a virtual profile located on the XY plane of the frame. Okay. And for sweep command, the basic logic is matching and fitting all the profiles and then get the result. So the z-axis and the x-axis will decide the orientation of the virtual frame and the profile on it. Then the sweep shape will be controlled according to the settings. Okay, first let's see the z-axis settings. We use this option to control the z-axis of the frame. And by default, it's tangent to the path. You can see it will always tangent to the path. And now let's see the drop-down list. And there are more settings. The second one is tangent to a curve. Okay, here we use a curve. Okay, here you can see we get a curve here. Okay, now we use the sweep again. Okay, and then we change the z-axis to tangent to the selected curve. Now you can see actually the shape is changed. And then you can see the z direction will be tangent to the new curve. Okay. And the third setting is a fixed direction. For example, here we can change the z direction to the default world z direction. Okay, here you can see the result is also changed. Okay, this is the settings of z-axis. Okay, we keep it tangent to path. Okay, next I'll show you the x-axis settings. Similar to z-axis settings, we can use this option to control the orientation of the x-axis during the sweep. By default, the x-axis is minimum twist, which means the x-axis is constrained to minimum rotation. Okay, and now let's see the drop-down list. And the second one is x-axis curve. This one is similar to the z-axis curve, so we'll skip it. Let's see the next one. The next one is fixed direction. Here we need to define another direction. After the definition, the x direction will be the vector product of the picked direction and the z-axis. Here we can make another vector. Okay, here we got an axis here, and we do it again. Sweep, profile, path, And for the x-axis, we use fixed direction. And for the direction, we select the axis we just created. And here you can see the x-axis will be the vector product of the z-axis and the selected axis. Okay, and if you see it in the top, you can see actually the sweep feature is a little bit rotated, right? Okay, this is the result. Okay, and here you can see the last option is face normal. For this one, you need to define a face. After that, the x direction will be the vector product of the z-axis and the face normal direction. Okay, here we use another case. Okay, here we use this case. So first we select the profile and the path. Okay, here you can see by default the x-axis is set to minimum twist. Here you can see the x direction or the y direction is not always parallel to the face normal direction. Okay, here we can change it to face normal, and then we select the cylinder face. And here you can see we get the correct result. So this is all about the sweep feature and the orientation settings. Okay, and next I would like to show you the swept road. Okay, swept road. For swept road, all you need to do is define its path and the diameter. Okay, here we use this as the path. And you can make it a solid pipe, or you can make it a shelled pipe. Here we just make it a shelled. So which means we need to define the outer diameter and the inner diameter. Here we just keep the default 10 and 8. Okay. And also you can see the path is not a tangent path, right? But don't worry, we can check the fitted corner. You can see the result will be tangent, and also we can adjust the fitted radius like this. Okay, click OK. Now we can get the result. So this is often used for creating some pipes. Okay. And the next one I would like to show you is the profile swept road. Here, profile swept road. This one is very similar to swept road, but the only difference is we need to define the profile. Okay, here we got one profile. Okay, and the path here. Now actually we can see the result, and after we click OK, you can see the result will be like this. Okay, and here you can see the angle is 90 degree. We can change it to 0, and you can see this will be the result, a different result, right? Okay. So this command is often to create some still product. Okay. And the last one is spiral sweep. Spiral sweep here. And for spiral sweep, it's a little different. Now you can see the required input is a profile and the axis. Here we can use the z-axis. Okay. Now you can see we need to define the turns, the number of the turns, and also the distance between two turns. Okay. And also you can see we have more options like the lead in or lead out. Okay, here we just make it a lead in, and also the lead in radius and angle can be changed as required. Okay, and for the offset settings, actually it's similar to the extrude, so we will not repeat it. And also we have one more option. It's about the revolve direction. It can be clockwise or anti-clockwise. Okay. And we click OK, and we get a result like this. So as you can see, this command is proper to create the solid thread. Okay. Okay, the next feature I would like to show you is loft. We use one or multiple profiles and one or two drive curves to create a loft feature. And in the loft feature, we can define the boundary constraints as G1, G2, or G3 continuity. Okay, and in ZW3D, we have three loft commands: loft, drive curve loft, and the burial loft. So here I got a form to show you the difference between these three commands. Okay, now let's see the first one, loft. So for loft, you can see the profile the profile quantity need to be at least two profiles, and there is no drive curve uh, in the loft command. And in loft command, you can define the boundary constraints. And below you can see some cases. So this one is about four profiles to make a loft. And this one is a start point and a profile to make a loft feature here. Okay, now the second one, drive curve loft. So for the drive curve loft, the profile quantity can be one or multi. Okay, and there is a drive curve in the drive curve loft. And also in the drive curve loft feature, you can define the boundary constraints. Okay, and below you can see a typical case. Okay, and the last one is burial loft, which means you need two drive curve to make a burial loft. And in the burial drive curve loft, and in the burial loft, there is no boundary constraints to define. Okay, and here you can see a typical case. We have drive curve 1 and drive curve 2, and we have multi profiles to make a burial loft feature. Okay, and there are some common options in the loft I would like to show you. The first one is boundary constraints. So in the loft feature, you can define the continuity for the start side and the end side. Here you can see you can make it connected, which means G0, and also tangent, which means G1, and also curvature and flow, which also means G2 and G3 continuity. And the second option is connection lines. So in ZW3D, actually you can adjust the connection lines to make the result more reasonable. Okay. And now let's move over to ZW3D to show you more details. Okay, now let me show you the three commands one by one. The first one is loft. So for loft features, actually you can see there are several loft types: profiles, start point and the profiles, endpoint and the profiles, and both endpoints and the profiles. In this case, we only have profiles, no points, right? So here we use the first one, profiles. And then we select the first profile, it's the circle. And here we can define the start point if the current point is not what we want. Here we do not need to change it. Okay, we add it to the list. And then we select the second profile. And here you can see the start point is not what we want, because it will rotate the loft shape, right? So here we need to define a start point. We move our cursor here, and then we select a start point. Okay, we set the middle point of the length. Okay, and here we can click OK to get the result. Here you can see that default result is pretty good, right? But as I said before, you can still manually change the connection line to control the shape. Here I'll show you two methods to do it. Okay, we redefine it. The first method is you can change the start point for the profiles. For example, here we change the start point for the rectangle. Okay, we delete the original one and we repick. For example, here we pick the corner point of the rectangle. Okay, now we can click OK to get a new result. Okay, this is the first method. And then the second method is we can modify the connection line directly. Okay, we redefine it. And here you can see connection line option. Okay, so step one, we need to generate the auto connection line. Okay, now you can see there are 4 connection lines here. 1, 2, 3, 4. And here you can see for one connection line, there are 2 points inside. So if we want to modify the connection line, we need to modify the point. Okay, here we unpick the last point and we select another point. And here you can see the connection line is changed. And actually we do not need to change the point for every connection line. We just click again. And here you can see it will generate the other 3 connection line automatically. Okay, here we can click OK to get the result. Okay, this is the new result. Okay. Okay, this is the loft for profiles. And as I said before, we can do the loft for point and the profile. Here I'll show you how to do it. Loft. And here you can see we have 3 types. We just use the first type as an example to show you how to use it. Start point and the profile. So first we select the start point. It's this point. And the profiles. Okay, the profiles. And for this case, actually we do not need a boundary constraint. So we change it to none. Okay, now we can get the result. So this is about loft for points and the profiles. And I'll use another case to show you the boundary constraints. Okay, now we want to make a loft feature between these two, the start geometry and the end geometry. And meanwhile, we make it G2 continuity in both sides. Okay, now let's see how to do it. Loft and the start profile and the end profile. Okay. Now you can see the boundary constraints. By default is tangent. We can make the curvature. Now you can see it's smoother in both sides, right? It's more smoother. Okay, and even we can make it flow. It's much more smoother than the tangent. Okay. Okay, we make it a curvature, which is G2, and we click OK. Now you can see the result. Actually, we can display the zebra strip to see the continuity situation. Actually, you can see it's very smooth here in the connection area. Okay. So this is about the first loft command. Now I'll show you the second one is drive curve loft. Okay, the biggest difference between them is in the drive curve loft we have a drive curve to control the loft shape. Okay, now let's see how to use it. Drive curve loft. First we define the drive curve. Okay, and then we define the profiles. The first one and the second one. Okay, then we can get a result like this. Okay, and the other options are similar to the loft feature. Okay, and now let's see the next command. It's real loft, which means we have 2 drive curve in this loft command. Okay, now let's see how to use it. Real loft. The first drive curve and the second drive curve. Then we just define the profiles. The first profile, second, third, and the last profile. and click OK. Now we can get a result like this.